When you see the sunlight and sun shining so hard, you feel happy and full of energy. So we can also take profits of some of this light. So, since I have been very young, I always been interested in experiments and trying to mix things out, what happens. And after I finished my bachelor degree on chemical engineering, I was hesitating about going to a company, private company, or working in a lab. And for me, the feeling of working in a lab and sharing knowledge with everyone was more motivating than working for a company, for a private person, and keeping the knowledge in a very close environment. Our team is composed by 12 persons. We come from 10 different countries from all around the world. And of course, we come from different countries. We have different mentalities and different ways of solving problems and working. And also, some people are chemists, some people are physicists, some people are engineers. So we put together all this knowledge from these different fields. And this helps us to improve on our research. A solar panel, a solar cell, is a device that everybody knows, takes the light, the energy from the sun, and converts it to electricity. Usually, the most common solar panels that you can think about is the silicon panels that you can see are black color, are everywhere. Silicon is quite cheap and easy to find, but the difficulty and the expensive part of these solar cells is the fabrication because of the high temperatures, up to 1000 degrees Celsius. The perovskite is a structure. You cannot find it in the mountain or something. You can mix the components inside the solution, liquid, and then you print it on top of your substrate. And with very low temperatures, like 100 degrees, like the temperatures you can have in your home oven, you can fabricate these structures. That's why the final cost of the perovskite material is cheap, because it's easy to synthesize these materials. And the perovskites we are working on have these maybe 2-3 different organic parts. The ones we are working with, it's composed by an organic part and inorganic part. So it depends how you fabricate and mix these components. If your crystallinity of the perovskite is good, that's what will get you the most efficiency from the sun, because it can collect more photons from the sunlight and can create more electrons from these photons. And yeah, nowadays the efficiencies that the perovskite reads are comparable to the efficiencies of the silicon solar cells. Perovskite can be created from liquid precursors like an ink. So even the materials are cheap. If in the future we fabricate these in a larger scale, these solar cells, for the fabrication of these solar cells, you need a very low investment in machines. You can imagine that you can even print it at home with your computer printer machine. You can load this solar cell ink and you can print your solar cell at home. This can be the future. For now, the perovskites have this limitation. They are stable only for few weeks. So this is the research we are currently going on. And if in 3 years we could reach between the whole world community researching on this field, maybe 5-10 years from now, it will be a reality.
Tez günde ayırdı felek, eylen suna gelin eyle, suna gelin, suna gelin, tez mektup yaz bana gelin. İzin alıp sana gelip gün olaydı, tam olaydı, gittiğin yer har olaydı, yattığın yer har olaydı. Oy, oy, oy.
This new technology won't substitute the silicon solar cells, will be in addition of. Nowadays, some people doesn't want to put the silicon solar cells on top of the roof, but this new technology, you know, there are many different colors of solar cells that you can get energy from it. And maybe you can create these traditional roofs, red colored, but that actually they are solar cells instead of tiles, or covering other areas of the house that the common solar panels cannot reach, maybe the curtain shadows. And in the summer, these windows won't be a problem because the solar cells will protect the house from the sunlight, because the sunlight, instead of heating inside the house, will be producing energy outside in the window. Or you can even have the windows on the rooftop. And during the night you can see the stars, and during the day you get the energy. Yeah, there are many possibilities of this new type of solar cells. Perovskites can work both for getting electricity from sun or emitting light from electricity. You can work as a solar cell, so you put outside, you collect light from the sun and you extract electricity, so you can have a solar cell. But if you assemble the device in a different way with the same material, you can put external electricity and also make this perovskite work as an LED, organic LED, and create light. Energy is a big constraint for the developing in Okinawa. Less than 1% comes from renewable, but yeah, this can totally change. The addition of every contribution, if there is solar panels in each individual house or small communities all around the island, in the future may represent up to the 50% of the energy consumed in Okinawa. And if most of 50% of the energy comes from renewable, yeah, Okinawa for sure will become more independent, and people will feel this freedom. The real benefit is that first the people and the children even more, they have closer contact with science and technology. Yeah, few universities are in Okinawa, but this one is especially created for research and showing what we are getting. And it's a very international team, so now Okinawa is known all around the world because of research, because of new findings on biology, on technology, on energy. I know this research will be original from Okinawa, and I think this is a pro for me and also for the people around me. So this is one of my motivations. I thank Okinawa for all the island and the people did for me. I want to thank them. Arigato.